Section 10.2, mole mass and mole volume relationships. So here's our objectives: be able to describe how to convert mass of a substance to moles and moles to mass. So in other words, grams to moles, moles to grams. Also identify volume of a gas at STP and be able to convert that also. All right, so let's talk about the mole-mass relationship. And a lot of times you'll hear me say it's moles to grams and so on, because mass we measure in grams. And the way that you do this is you take the molar mass of an element or compound and you use that relationship where you know that 1 mole is so many grams. Use that to make a conversion between those two. So for instance, if I want to know how many grams of something there is, let's get that back. Let's say I want to know how many grams of water if I had 2.5 moles of water. Then what I need to do is multiply by the mass in grams on the top, moles on the bottom. In other words, 18 grams, that's water, is 16 for oxygen and 2 times 1 for hydrogen. 18 grams of H2O over 1 mole. And that's how I would figure out what that is. So that'd be 36 and 7, 43 grams H2O. All right, take a look at page 298. Pull that up in your book. Probably a little easier to see than what I have here. And the question says, the aluminum satellite dishes in figure 10.8 are resistant to corrosion because the aluminum reacts with oxygen in the air to form a coating of aluminum oxide, Al2O3. This tough, resistant coating prevents any further corrosion. What is the mass of 9.45 grams of aluminum oxide? So, once again, set it up the way we've set up everything else. You want to know how many grams of Al2O3 given that you have 9.45 moles of Al2O3. And at that point, then you need to look up, well, what is it for aluminum? So if you look aluminum up on the periodic table, you'll find that it's like 27 grams. So you've got 2 times 27 plus 3 times 16, and that totals to be about 102. So 1 mole on the bottom, 102 on the top. And that's how you're going to convert. So you're going to end up with 964 grams total. Okay, you try problems 16 and 17. Stop the video, try those first, and then I'll work them out for you. Alright, so number 16 says, find the mass in grams of 4.52 times 10 negative 3 moles of C20H42. So, how many grams equals 4.52 times 10 to the negative 3 moles of C20H42. So the way that I'm going to do this is I'm going to say 1 mole of C20H42, and on the top I'm just going to kind of do the calculation as we go. So it'll be 20 times 12 plus 42 times 1. And if we calculate that out, that should give us 282 grams. So 282 grams is its molar mass. So if we take those two times each other, should end up with 1.27 grams. That's for 16. 17 says calculate the mass in grams. So how many grams? If I have 2.50 moles of iron 2 hydroxide, now if it's iron 2, we know that it's going to be 2 hydroxide because each hydroxide is a -1, so we need 2 of them. But this is why it's important that you still understand how to write formulas for names, because you're going to need to do that all the time. So 2.50 moles of FeOH2 times 1 mole of FeOH. And if I look that up, iron 55.85, I think. This is a 2 here. Plus 2 times oxygens, 2 oxygens, and there's 2 hydrogens. And if you calculate all that, that should be 89.8. Now be aware that if you write it this way and then try to do it all on the calculator at once, make sure that you kind of think of it as having parentheses all the way around it. I think you're actually better off calculating it and then writing it on top. That's the way I usually do it if I want to figure it out. And when I take 89.8 times 2.5, I get 225 grams. Okay? Well, if we want to figure out moles from grams, it's just the opposite. On the other one, we had grams on top and moles on the bottom. Here we have moles on top, grams on the bottom. So take a look at problems on page 299. It says when iron is exposed to air, it corrodes to form red-brown rust. Rust is iron 3 oxide, Fe2O3. How many moles of iron 3 oxide are contained in 92.2 grams of pure Fe2O3? So we want to know how many moles. So we're going to set it up the same way. How many moles of Fe2O3 given my 92.2 grams of Fe2O3? And then what I need to do is multiply by, I need moles on the top, so 1 mole on top, and then the molar mass of Fe2O3 on the bottom, which is 55.9 times 2 plus 3 times 16. That would be 159.6. And you can see all that right here if you need to see that. And that equals 0.578 moles. All right, let's, you guys, work out 18 and 19. Do those 2 problems, and then come back and check with me, and I'll work through them with you. Alright, so for 18, how many moles, if I have 3.7 times 10 to the negative 1, how about we just write 0.370 grams of boron? So what I need to know is how many grams of boron are in a mole. So I would look that up on the periodic table, find out that boron is 10.8 grams. And now I'm just going to take 0.37 divided by 10.8, and that should give me 3.43 times 10 to the negative 2, or 0.0343 moles. Okay. 19. How many moles are in 75 grams of dinitrogen trioxide? So, how many moles equals 75 grams dinitrogen, so N2O3, and just convert. We know 1 mole of N2O3 is going to be 2 times 14. Can't write very well. Let's erase that and start that over again. 2 times 14 plus 3 times 16, and that would be 76 grams. So 75 divided by 76, we're going to get 0.987 moles of N2O3.